Hi, everybody, and welcome to Room 9, the region's largest classroom. My name is Mrs. Brewer, and I am a third grade teacher at Gordon Bush Elementary School in the East St. Louis School District. And boys and girls, you keep getting me when I'm trying to have some delicious snacks. Ugh. Well, you interrupted me again during our Freaky Fraction week leading up to Halloween, boys and girls. So you want to see what I was trying to eat today? It's not as sweet as the cinnamon rolls were yesterday, okay? But today I have been busy not eating fractions, boys and girls. Can you guess what I've been eating? You're exactly right. I have this pizza here. Doesn't it look just as delicious as my cinnamon roll from yesterday? What? You don't think it looks as good? Why not, boys and girls? Because you don't like pepperoni. I get it. You don't like pepper. What are you, more of a sausage person? What do you like on your pizza, boys and girls? Okay, all right. Do you know I have a son who doesn't even like pizza? Can you believe that? Is that even possible, boys and girls? So looking at my pizza here, does this look a little better than my cinnamon roll? Do you think I'm able to share this pizza? Why do you think I'm able to share my pizza? You're exactly right, boys and girls. I'm able to share my pizza because this one's actually cut into slices, right? How many slices is my pizza cut into? Do you know? Can you count them? You're exactly right. My pizza is cut into 8 slices, okay? So what fraction? Why do you think I can use fractions for this? Why do you think I just brought up fractions? Ah, you're exactly right. I can bring up fractions here because each piece is what? You're right, it is equal. So it doesn't matter if you have this slice right here or this slice down here, they are all the same size. Would you agree, boys and girls? Okay, good, good. I'm glad you agree with that. Now, so what happens if I would give you over there this piece? And what happens if I give you over there these pieces? Would that be fair? If these pieces went to you over there and this piece went to you over here, would that be equal? Would that be fair? Why not? You said each piece is the same, right? Okay, but what? Oh, but you over there are getting more pieces. So if you had more pieces, then you would probably have more what? More pizza, right? So the amount that this person over here got, these 1, 2, 3 slices, you're telling me would be greater than this person over here that just got 1? Would you agree with that? Oh. But one thing we can agree on is each piece is the same size, right? Okay. How many pieces when I gave you over there pizza, what was my pizza cut into? Oh, so it was cut into 8 slices, right? What about when I gave you over there these pieces here, these 3 pieces? How many pieces was my pizza cut into? The whole. Oh, so the whole always stayed as how many pieces? You're right. My whole always stayed as 8 pieces. So thinking freaky fractions, That must mean then that my denominator stayed the same, you think? Or do you think that my denominator changed? Was it the same? Lean this way if you think the same, or if you think it's different, lean this way. You're right if you're leaning this way because my denominator stayed the same. I always had 8 pieces of pizza, right? Even if this person over here had 3 and this person over here had 1, the whole pizza always stayed as 8 pieces, right? I didn't cut any more. I didn't smush 2 together, did I? No, they always stayed the same. So if we look here at my pieces of pizza here, if this person here got how much? Right, this person here got none, right? 0 pieces of pizza, 0 eighths, okay? What do you notice? How much did this person get here? Oh, think freaky fractions, boys and girls. What fraction of my pizza is on this pan? All right, 1/8, right? Still 8 pieces though, right? One of the 8 pieces. What about over here? Or what fraction do you see on the pan still? All right, we see 1/8, 2/8, right? 2 pieces left, 8 in my whole, right? Here, what fraction of my pizza do I have? You were right, it is 3/8. 1, 2, 3/8. Okay, what about here? Can you guess? Getting pretty quick with these now, aren't you? Right. Here I have 4/8. 1, 2, 3, 4. What's happening to the amount of pizza, boys and girls, that's left? Oh, so as I go from 0 to 1, 2, 3, and 4, the amount of pizza is getting what? You're right, it's getting greater. We have more pizza, right? The more slices we have, the more pizza is there, right? Anybody disagree with that? Okay, so let's think about the fractions we're talking about here, boys and girls. 0/8, 1/8, 2/8, 3/8, 4/8. What's happening to the size of those fractions, do you think? Do you think that they're getting greater? Dab it out for me if you think they're getting greater. If you think it's getting smaller or less than, floss it out. What do you think? Are we getting greater or less? Oh, we should be dabbing right now. You're exactly right. Because we are getting greater. The more pieces you have of that fraction, the more pizza you have, right? Right. So if we compare, oops, here was our whole again, in case you forgot what it looked like, boys and girls. So as we compare 1/8 as opposed to down here, what fraction of my pizza do I have? You're right, 6/8, which is greater. If you think 1/8 is greater, put your hands on your head. If you think 6/8 is greater, put your hand on your chin like, 6/8 is bigger. You're right, I should see your hands on your chin because 6/8 is greater than 1/8. But did our denominators ever change, boys and girls? Looking from 0 all the way to what fraction is this right here do I have? You're exactly right, 8/8. You're exactly right, boys and girls, okay? So did my denominator ever change? You're right, boys and girls, it did not. It always stayed as what? 8. We never, like I said, we never cut our pizza into more slices, did we? Nope, we didn't smush them together to make less, did we? Nope. Our denominator stayed the same. So what is changing then? You're right. Our numerator is changing. So if my denominator has stayed the same and my numerator is getting bigger, if we were talking about comparing fractions again, boys and girls, could I compare denominators if they're the same? You're right, they're equal. So how would I compare this pizza up here to this one down here? I'd have to look at what? Not the denominator, but the, you're right, boys and girls, I'd have to start looking at the numerator. You're exactly right, okay? So let's see what I mean here. Look at these two rectangles that I have here. What do you notice is the same about them? Oh, you're right. They're both cut into how many pieces? You're exactly right. They're both cut into 9 pieces. So if we're looking at the shaded, boys and girls, what fraction of mine here on the left is shaded? The red rectangle. What fraction is shaded? You're right. We know that 9/9 is shaded, or the same, we know 9/9 is also equivalent or equal to what? You're right, 1 whole. What about over here? What do I have here, boys and girls? What fraction is shaded? You're exactly right, boys and girls. 1/9 is shaded. So now if we had to compare, which shape has the greater amount shaded? Can I look at my denominators here? I can't, can I? Because they're both the same, right? Even though I can look at both these shapes, I know not the same as shaded, is it? No, so I know they can't be equivalent or equal. So now I have to look at what? I need to look at my numerator. So if my denominators are the same, I'm going to look at my numerators and compare. Which do you think is greater, boys and girls? If you think the 9 is greater, I want you to give me 9 zombie walks. If you think the 1 is greater, give me 1. What are we going to do? How many zombie walks are we going to do, boys and girls? You're exactly right. I should be doing 9 because 9/9 is greater than 1/9. Because if I look at 9, just the numerators, since the denominators are the same, 9 is greater than 1. So 9 pieces would be more than just 1, right? Who's with me still? Give me a Dracula laugh. All right, boys and girls. Greater than still. All right. So let's look at these shapes here. What fraction on the left is shaded? You are exactly right. 1/4 on the left is shaded. What fraction on the right is shaded? You're right, boys and girls. It is 2/4. So which is greater? So what symbol would I put here? Would I put greater than, less than, or equal to? You are so smart. I should say less than. If you had it, give me a high five. All right, boys and girls, we're going to take a break real quick and we're going to shake those bones. So everybody stand up for me. Everybody stand up. Shake out your bones. Shake your bones. Shake your bones. Shake out your bones. What about your feet bones? Shake out your feet bones. Can't see mine, but I'm shaking my feet bones. Boys and girls, all right. Can you give me some more Frankenstein walks? Walk like Frankenstein. Walk across the room like Frankenstein. Now turn around and walk back the other way, boys and girls, like Frankenstein. Ooh, math. Oh, need fractions. All right, boys and girls. So give me some monster mashups, okay? So we're gonna squat down low and reach up high. Ready, monster mashup? Squat down low. Reach up high. Let's go. Squat down low. Reach up high. One more time. Ready? Squat down low. Let's reach up high. All right, boys and girls, let's be like vampires now. I want to see your fractions. All right, so here we are back to fractions, boys and girls. Freaky, freaky fractions. All right, let's look here. And it is not, there's our 1/4 and our 2/4, boys and girls. We know 1/4 is less than 2/4. All right, let's look at these. Let's compare these. What do we notice about the number of pieces in the whole? Right, they're both divided into the same amount of pieces, boys and girls. You are exactly right. What fraction is shaded on the left? You are right. 3/6 is shaded on the left. Woo, I got a spirit taking over my computer today, boys and girls. Okay. What fraction is shaded on the other side? You're right, 2/6. Now, how do I compare them? Right, I can't use the denominator, boys and girls, because it is the same, right? And I know it's not the same amount shaded on both, is it? So now I need to compare my numerators, okay? So 3 pieces shaded is what to 2 pieces shaded? You are right, boys and girls. It is greater than. Great job, boys and girls. Great job. Let's look at another freaky fraction. What do you think here, boys and girls? What do you notice again about these shapes? Not just their blue. You're right. They're both divided into 3 pieces. So now what do I need to do? You're right. Now I need to look at how many pieces are shaded, right? So what fraction on the first circle is shaded? You're right, it's 1/3. What fraction on the second circle is shaded? You put the wrong, the ghost. You're right, 2/3, boys and girls. All right. And so is 1/3 greater than, less than, or equal to? Shout it out to me, boys and girls. What do you think? Give me your best monster walk if you got less than. Walk like a monster. I guess like a zombie. All right, let's keep going, boys and girls. Let's see how we're doing with this. Good job if you got this. All right, ooh, me, circle. All right, what do we notice again about these? You're right. The wholes are divided into the same amount of equal pieces. What fraction is shaded on the first monster circle? Went a little too far. You're right, 1/8. What fraction of the circle is shaded on the second one? You are correct, 3/8. So is 1/8 less than, equal to, well, let's start at the beginning. You think it's greater? Dab for me. You think it's equal to? Put your hands on your hips. Or do you think it's less than, and we're going to floss? Is it greater, equal, or less? And we're flossing. What do you think? Oh, you're exactly right, boys and girls. 1/8 is less than 3/8. Good job, boys and girls. Good job here. You ready for another one? Okay, so now let's look at another way to think about this. We looked at our pizza, but let's look on a number line. Okay, that's another way that we can tell and compare fractions, right? Okay, so yesterday we had looked at a number line and found where 1/2 was, right? And compared our fractions to see if it would be greater than or less than 1/2, remember? So what do you notice about the number of pieces the further we move down our number line? The number of pieces that are shaded. Let me rephrase that. You are exactly right. The number of pieces that are shaded increase, right? They get bigger. It's greater than. So the more we move down our number line, the bigger the fraction is, right? The more pieces we have shaded. All right, boys and girls, how about a treat? You ready for a snack? I'm ready for a snack. Actually, I'm ready for some water here. All right, so here are some cupcakes I made too, boys and girls. Pizza and cupcakes. What a great lunch, right? All right, so we want to start comparing some of these cupcakes. So I've got a quick question for you. What fraction of the cupcakes, what is the fraction for the cupcakes that have chocolate icing? So look at this and tell me, what fraction has chocolate icing? Oh, I really want cupcakes. You want cupcakes now? I really do. You are correct if you got 3/4. High five. Okay. Using the same set of cupcakes, what fraction of the cupcakes do not have chocolate icing? You are exactly right if you said 1/4. Okay. So still looking at these cupcakes. Let's compare. Let's compare the number of cupcakes with chocolate frosting to the number of cupcakes without chocolate frosting. Okay, so if we're looking at 3/4 or 1/4, do we have more cupcakes that had chocolate icing or more cupcakes that did not have chocolate icing? What do you think? Should I put greater than? We'll dab it. Are they equal? Put your hands on your waist. Or do you think it's less than and we're going to floss? What do you think? That's right. I should see you dabbing it out because 3/4 is greater than 1/4. Great job, boys and girls. What do we notice about our denominators? They're what? You're right. They are the same. So when our denominators are the same, we have to look up to our numerators. You're exactly right. Okay. We have to compare numerators. Denominators are the same. We compare the numerators. 3 is greater than 1. Okay. So now I have one I want you to try on your own again, boys and girls. Maybe I shouldn't show you. You promise you won't be too scared if I show you this? You promise? All right, so here's our number line again, boys and girls, showing you this. That was pretty spooky, wasn't it? That 1/4 comes before 3/4, and the further I move down this number line, the bigger the fraction, right? All right, whoo, you scared? You scared yet? Okay. What fraction of the monsters have no arms? I'm going to give you about 20 seconds, 30 seconds, figure out what fraction of the monsters have no arms. Go. Can you find them? What'd you get? Great job. 2, 6. One monster, 2 monsters don't have arms out of 1, 2, 3, 4, 5, 6 monsters. Okay? What fraction of the monsters have 2 eyes? About 5 more seconds. All right. What'd you get? Did you get 4/6? If you did, great job. Here's 1, 2, 3, 4. 4 out of the 6 monsters have 2 eyes. So now let's compare. What was greater, boys and girls? The number of monsters that have no arms to the number of monsters that have 2 eyes. So we have 2/6 and 4/6, boys and girls. Which is bigger, 2/6 or 4/6? You are exactly right, boys and girls. 2/6 is less than 4/6. Did you get it? Were you scared? Did you get it? Did it scare you today? Working on this? No? No? You weren't scared of my monsters? Okay then, boys and girls, you were doing better than me. All right? All right, so we now know how to compare fractions that have the same denominator. All we have to do is look at what? Look at the numerator. Look up top, right, boys and girls? All right. So boys and girls, it is time for us to say goodbye today, but I will be right back here tomorrow with some more freaky fractions. So don't go anywhere. Be here at 2 o'clock tomorrow, same time, same place. Bye.
Teaching in Room 9 is made possible with support of Bank of America, Dana Brown Charitable Trust, Emerson, and viewers like you.